everybody to the AURIX Knowledge Lab 2021 Battery Management and Control. Today I will highlight the AURIX safety and security introduction and Automotive PSoC ecosystem in the battery management system application. My name is Omar Triki, and I am Product Marketing Manager for Automotive MCUs at Infineon, and also Global Responsible of the Preferred Design House program. So basically, AURIX is based on tri-core architecture, which combine three elements: the DSP, the RISC processor, and the microcontroller. And basically, it's featured from with his real-time performance, scalability, security and safety is key for AURIX, and also the pin-to-pin compatibility. Since we are very limited with time, so I wanted to go directly to the portfolio and talk more about the key features inside this portfolio that we can save some time. So basically, we have the first generation AURIX TC2XX, as it's shown here with the portfolio. Let me just put the laser. So here, as we can see, for the portfolio, scalability is shown and is highlighted since it starts with the low-level subfamily with TC21X 512 kilobyte up to 8 meg with the TC29X as high-level subfamily and umbrella device. All the parts that we have here are ProZeal ISO 26262. Since it's our key features, the safety, our basically microcontroller has been designed based on a safety, not much more than a safety island, but also the design of the microcontroller was based on the safety reaching ASIL-D with the safety measures. Not only, but also a different variety of packages here, offering a lot of solutions for different project requirements. Also, we can see that we have up to three cores, triple cores, basically with the S showing the single core, the L, the lockstep core, the single lockstep core, and dual core and triple core. So you have, beside 3 cores, you have also the possibility in most of the devices to have a lockstep core for the safety. We have also security for most of the devices here, and basically also we have security with the hardware security module HSM. We are also benefiting with the pin-to-pin compatibility here, which is very key in different projects, specifically in the hard time of allocation, with the different possibility and variety of solution that AURIX can offer here. Then, following the market basically requirements, AURIX TC3XX was enhanced based on the improvement of many of our functionalities. Which first one was the performance. So with the second generation, we have basically enhanced the number of CPUs up to 6 CPUs running at 300 megahertz with the new direct flash access path, and also a new tri-core 162 generation. As you can see here, the 6 CPUs, each CPU is running as following. Also, we have enhanced the ADC, improvement of existing the ADC here, as you can see, and the reduction of capacitive load. Ethernet has also been enhanced with 1 gigabit Ethernet and QoS services, and Delta Sigma as well. The concept have been enhanced. As you can see here, the full EVITA compliance now for the security for the second generation TC3XX means that the security has been also improved here. What is key as well, that the memories, larger SRAM and larger flash memories as well for the portfolio that you can see later on, that I will show later on basically, and with an SRAM flash ratio increase as well. We have also adapted new SPU concept for the second generation for ADAS application, but also the safety has been enhanced with LBeast and MBeast upgrade. Not only, but also we have now with the second generation a standby control model unit, with the low power modes. And here is the result of the second generation, AURIX TC3XX, with a larger portfolio, with also scalable portfolio, high performance portfolio, and with the capability of matching all the project requirements. So as you see, all the devices are running under 300 megahertz. There are some specific cases where we have the marking option of taking the 200 or 160 megahertz. So our portfolio starts with the TC2, basically TC32X series. We're running at 300 megahertz with 1 meg up to 16, and which shows this basically the possibility of AURIX to target a wide range of application, from braking, EPS and BMS to radar, corner high, front radar, corner radar, but also up to the domain control, telematics, and also gateway, high-end EMS, and front LRR. Connectivity has been improved, as mentioned, with the LIN up to 24 channel and also IPC up to 2 times 320 Mbit. Beside this, we have the 6 tuple core, up to 6 cores, and also single lock step core that can be added, of course, which is added, all of it. All of the portfolio is ASIL-D, ISO 26262 compliance for all devices, and we have received, of course, the safety certification from TÜV in 2018. Pin-to-pin compatibility is also available here in the AURIX TC3X6, and not only the pin-to-pin compatibility, but also software compatibility here between the devices. Here, since we are talking more about the battery management system, so I wanted to highlight basically how we can map the different devices that we have into the battery management system requirements. So as you see here, for the 48 voltage battery management system, then the low end or middle end subfamilies are the ones that might match the project requirements that we are looking for the TC332 or the TC364 as a mid-end subfamily. For the high voltage battery management system, also the TC37 can be considered beside the TC36. But when we include the function integration, then the TC38 would be the best device to match your application. Of course, this depends on the project requirements, but with the scalable portfolio, you will find the device that is needed for your project. So for our AURIX, also we wanted to see what are the main challenges for the battery management system. And according to these challenges, we have also highlighted and emphasized the point that AURIX features are basically made for these challenges. So the challenges of the BMS application in OEMs, different OEMs and tier ones, are functional safety. With here AURIX is the leader of the functional safety. When it comes to safety, then AURIX is the #1, with the implementation of a safety measure in hardware, LBIST, and also an ASIL-D on all the devices. Security is also key for BMS, which is fulfilled through our HSM Evitaful and the symmetric and asymmetric crypto accelerators. Also time to market, so maybe I forgot to mention it in the previous slides, but all the products, all the devices and all the products are already in mass production with a scalable portfolio, which make life easier when it comes to migration between generation and application. Also, AURIX is capable of reusing multiple concepts, same as FUSA and security concept. Energy efficiency, this is also achieved with an extremely low current consumption from AURIX, and battery SOH checks over long parking periods, basically. Zero downtime, sorry, is basically achieved also with our software over-the-air SOTA update. Here, a small overview or example of how AURIX is used in a battery management system, with additional growth expected, of course. So here, as you can see, the microcontroller of AURIX as a battery management controller. This is connected to SMC, which they are connected to the different blocks, including the cells. This SMC isolated control here is connected to the microcontroller, ensuring battery monitoring with a continuous control of critical cell characteristics. Also, a battery lifetime extension as you can see in the block diagram, by optimizing the life of the battery and limiting deep battery discharge. But also here, the battery protection, which is also linked to the microcontroller, that ensure a safety management, including crash mechanical strain detections. Why AURIX is the right fit here, since it has a strong positioning at EU and Chinese OEM for 48 voltage. AURIX has a strong footprint in most of the OEMs and the Chinese OEMs and European OEMs for battery management systems, with its ISO 26262 certified from TÜV. But also we have a strong ecosystem that unfortunately we don't have time to mention it in this presentation, but our ecosystem and software and tool chain also helps a lot our hardware to be defined for the BMS application, with the reuse of the concept and the reuse of the software, but also with the MCAL and AUTOSAR. We have also strong product roadmap for the next years and also scalability family concept. A little more about the functional safety. So as mentioned, the AURIX was designed for functional safety, the hardware basically with three-layer access protection, memories, peripherals, but also global registers. So it's much more than a safety island, with here a small teaser, I would call it, on how here the safety measures are acting continuously on our microcontroller, with safety measure over all peripherals and all the points that you can see in our microcontroller, from a safety measure from flash ECC to the safe DMA here, basically, and sorry, to the safe SRI here, basically, and also to the self-test and to the power supply monitoring. In order to support this safety concept, we have everything documented in 50K lines FMEDA, which will help you with the your safety journey. In order to start with AURIX, since it's a quite different architecture with the tri-core architecture from many of other microcontrollers, so we have a strong portfolio of kits, of course supported by our by Hitex. So we have, for the first generation, the light kits as the starter kits. They are supported also by AURIX Development Studio, but where you can find the use of Arduino Uno compatible platform, but also the FTDA based debugger with micro USB. We have also the shield body, which is compatible with the 100 of Arduino application shields, and if evaluation licenses are available. The TFT, so each subfamily that we have seen in the portfolio have a dedicated TFT with an additional touchscreen display for convenient handling. All the TFTs are available through our webpage. Same when you are starting a project, and triboard is needed for getting started. Advise also to try to basically to evaluate the software, and also we can make the first full evaluation board for development and to debug your first program. And this is available for all subfamilies or silicons from the first and second generation. Of course, all these boards are available via the eShop of Hitex, so you can basically easily purchase them in the Hitex eShop. Same for the second generation with the light kit TC375. Additionally, there are the Ethernet P, and we have also the shield body for TC375, same as the first generation. Also the TFTs. Each silicon has a TFT with a touchscreen display, but also we have the TC334 light kit for starter kit, which coming soon, with for low-end devices and also for BMS applications. Now I wanted to have a small overview of PSoC. This will not take too much time, but this is good to know, as we have PSoC is a one-stop shop for automotive HMI and smart sensors, targeting the smart ignition systems, intelligent battery sensors, from door handle and foot kick detection to liquid level sensing as key application. Also, PSoC could be is the first choice when it comes to biometric and navigation, touchpads and touch screens. Here, basically, also a small overview on our PSoC family, Automotive PSoC. We have the PSoC 4S with the architecture ARM Cortex architecture M0. So this also in BMS application, some cases or project requirements that could be combined with AURIX. So programmable analog, robust HMI as well, and flash memory is between 16 up to 384 kilobytes. Or PSoC for high voltage MS is coming soon with an ARM M0 plus MCU, ARM Cortex M0 with the robust HMI and 12-volt LDO. We have also the PSoC for high voltage PA with the precision analog, 12-volt LDE, and the lane PI and ASIL-C compliant. The only device that will be ASIL-D compliant is the one that you are looking for this presentation, is the PSoC ultra high voltage BMS with an ARM Cortex M0 for low-end application like 128 kilobyte up to 256. We have as well the True Touch and fingerprint devices with the very high sensitive capacitive measurements of up to AUTO PSoC. Here is also the roadmap and the portfolio, mainly an overview of the portfolio, I would call it, of our scalable portfolio for PSoC 4. So it starts with the PSoC basic subfamily of PSoC 4000 running at 16 megahertz, up to PSoC 41000L and 42000L running at 48 megahertz with 2 CAN and an USB 2.0. Sorry. And also then comes the PSoC 41000S with a higher performance and the KNFD. This is also shown here with this arrow, with the level of safety is also increasing, and also the performance here, depending on the needs of your project. We have also the PSoC 47000 Plus with an inductive sense and 128 and 16 kilobyte. What you have also for ASIL-B and also ASIL-C is PSoC 4 high voltage MS, targeting mainly HMI and smart sensors. Also PSoC 4 high voltage PA that we are mentioning along the PSoC 4 BMS targeting battery sensors. Coming also soon is the PSoC ultra high voltage wireless BMS with an ASIL-D and a dual core lockstep. Here's a short example on PSoC for BMS. For battery module here we're running at 400 volt, 800 volt, which is connected to the cell balance, which are basically performed via the PSoC, as you can see, the PSoC 4S, PSoC 4 high voltage MS, and PSoC ultra high voltage BMS. Not only, but the PSoC here family will also perform the battery junction box here, which is linked to the cell balance according to this circuit basically, and also the current sensors is also here considered linked directly to the digital voltage isolator here. Okay, and why PSoC might be the right is the right choice basically for cell balance and current sensor is because of the functional safety support up to ASIL-D, wireless BMS with the BLA monotonic integration, but also high precision analog performance with complete analog front-end integration. For your information as well, the PSoC 4S is already in production. The PSoC 4 high voltage will be soon available with the design up to 1 year, and the PSoC ultra high voltage BMS with the design up to 2 years. Just for your information, since we had a very few time today, I wanted to show if you are interested in more documentation, feel free to visit our webpage with the documents. You can see everything related to AURIX, PSoC, and Traveo 2. You can also access our My Infineon and register there, but also there is here some, I would say, guideline web pages, like a kind of user manual of where to find what for AURIX and where to find what for PSoC 4 and where to find what for Traveo 2. So you can click on these web pages and check all available documentation online for these products. I hope that I didn't exceed the time, and sorry if it was too long, but thanks you for your attention.
We will now talk about functional safety on the AURIX and how to perform it in the software itself. So we have introduced Hitex SafeTpack about 2 years ago. And what is Hitex SafeTpack? SafeTpack is the safety solution for the AURIX TC3X microcontroller family. And SafeTpack is designed to cover the most common AURIX safety manual requirements for a lot of applications in automotive and industry. Maybe you remember this picture from Omar's presentation. The AURIX has a lot of built-in hardware methods. And as Omar said, there's a lot of documentation you have read to understand the AURIX and the safety mechanisms and so on. And that's the reason why we developed Hitex SafeTpack. So to reduce the complexity with the SafeTpack in terms of functional safety and the AURIX and save time and money. Concentrate on your application know-how. Reinventing the wheel costs time and money. And with SafeTpack, we cover a lot of AURIX know-how for you. SafeTpack is a ProSil ready and provides a rapid way to achieve your ASIL goal. SafeTpack saves times, money, and at least your nerves. What does SafeTpack offer? SafeTpack provides interfaces to execute and evaluate a startup test. SafeTpack supports the necessary internal safety mechanisms, SM, external safety mechanisms, ESM, and safety mechanism configuration, SMCs, for a lot of application. SafeTpack provides cyclic tests and ensure the correct operation of the AURIX TC3X CPU, the internal buses, through a mixture of hardware and software module. SafeTpack manages the watchdog system and optional combined watchdog and power controller PMIC like the TLF35584, the TLF35585. Here's an excerpt of the AURIX manual, so the chapter Assumptions of Use. Safety mechanisms identified as per the safety manual are the safety mechanisms. This is a technical solution internal in the MCU by hardware software, so like the internal test. The external safety mechanisms, technical solution eyes and hardware software implemented at the system level by the system integrator. And additionally, the following term is used in the manual for describing required actions for correctly configuration of the safety mechanism. So if you read the safety manual of the AURIX TC3XX, there are more than about 120 assumptions of use in terms of ESM and SMCs. And a lot of them will have to be implemented in an application. Which ESM you will need is defined by the safety requirements of your whole system. How to implement these TC3XX safety mechanisms? Yes, several safety features and test capabilities are realized in hardware. So that's the great change from TC3X to from TC2X to TC3X, that all the self-tests are now realized in hardware. These are called, for example, power on built-in self-test, PBIST, or LBIST for logical built-in self-test. But on the other hand, there are a lot of things to do and have to be implemented. You have to implement, configure, and trigger and to evaluate the startup tests. You have to implement, configure, execute, and evaluate the runtime tests like SFR or die temperature sensor tests. You have to implement, configure, and handle functional and window watchdog like external TLF35585 and the AURIX internal safety watchdog. You have to follow the development process given to your safety standard, and much, much more. And that's why we designed SafeTpack for. This slide shows the execution of the safety mechanisms during the startup. You see here the blue rectangles. These are safety mechanisms provided by the AURIX itself at a startup. And after the analog startup, we have a sort of reset and will start the application. And here you see a lot of yellow rectangles which have to be implemented by you as an integrator, or we are provided by the SafeTpack itself. So as you see, here's only a small excerpt of the whole picture. There are a lot of things to do to ensure a safe start of the CPO and the whole application. On the other hand, SafeTpack provides tests for cyclic tasks. So for die temperature tests during running of the application, special function registers, which are often used in ASIL C or higher, and so on. So let's have a look inside SafeTpack. We have designed SafeTpack into two main packages. On the right side, you see SafeTpack Basic with the test handler, which executes the internal tests of the AURIX, which configures the SMU of the AURIX via an SMU driver of the MCAL, and so on. And that it's needed for startup and ESM support, and it's implemented in the so-called test manager, which you have to integrate into your application. So a demo code of a test manager will come with SafeTpack, but you have to implement your test manager because it reflects the safety requirements of your whole application. On the other hand, on the left side, there's a SafeTpack watchdog, which is the watchdog interface to the external TLF 35584 or F5 to the internal safety watchdog. And we have developed an own QSPI driver, which is slightly faster than the MCAL driver and performs the requirements on startup. On the other hand, there are add-ons like the startup test, so-called ABIST of the TLF. So this test is needed to ensure the correct start of the TLF. And for correct program flow, we have in separate package the program flow monitor. As you have implemented the test manager by integrating the SafeTpack, you have to implement the watchdog manager itself, and the watchdog manager is provided as a demo code as well in the SafeTpack package. Here's a rough overview over all packages. In all packages is included the complete source code of each package with a demo workspace, the Electro-PD tracers tool with plugins to configure the SafeTpack, all documentation you need for your work and for the safety assessment itself, and the 4 optional watchdog, the optional packages. And why we have divided SafeTpack in different packages? You only have to buy that what you need in your application. Have a look into AUTO. SafeTpack is developed as a complex device driver in AUTO, so uses the AUTO interface. SafeTpack is 100% compatible with the Infineon MCAL drivers, but nevertheless, SafeTpack can be used in non-AUTO environment as well. So, for example, PX Ross from Hitex has implemented SafeTpack and has a complete SafeTpack implementation for their real-time operating system. So SafeTpack can be used with or without AUTO. SafeTpack is fully configurable with Tracer Studio. All the plugins you need are included, and the Tracer Studio license itself. So it's the same configuration tool as for the MCAL drivers, and individual tests and the test sequences are configurable using the AB Tracer Studio. So what's inside SafeTpack? The source code, the demo workspace, the Electro-bit tracers and the plugins, example tracers configuration and demo code. So all you need to have a fast startup with SafeTpack. On the other hand, you have the user manual, release notes, the configuration verification manual, a demo description, and For your safety assessment at the end of the day, we provide a SafeTpack validation report and a safety case report. So if you're convenient with TC2X and SafetyLib, you will see a lot of things are very similar. So we designed SafeTpack according to the former SafetyLib. And if you have experienced developers with SafetyLib for AURIX TC2XX, they will be see that they can start very fast with SafeTpack. So here's an overview over all AURIX devices. The most of them are supported by SafeTpack today. If you don't find your device in this list, please contact us. Maybe we can provide a version for you. But about our experience with SafeTpack, we have sold a lot of SafeTpacks now today. These are the most common devices which are used outside the world. So we have a clear release plan for SafeTpack. The next item is that we have a maintenance release, which will be fully compatible to MCAL 2.00 and the respective compilers like Tasking and Hitex and the Tracer's version 26.2. We will support all the devices in one installation package, and we will have correction of errors in the first releases, so they will be corrected. On the other hand, the TLF 35585 will be available at the end of the year as well. Maybe there is some ESM or SMC you are missing. Please tell us. SafeTpack was designed to cover the needs of a lot of applications and was not designed for special applications. So maybe the one ESM is missing for you. Please tell us why, and we will show how we help you. On the other hand, we are working now for SafeTpack for the AURIX TC4X, the next generation of AURIX. Our services around SafeTpack and functional safety. We have a web-based training for SafeTpack integrators, and it's highly recommended for a fast implementation. And we give you first-hand information and valuable hints for safe and reliable integration. Here's an excerpt of the agenda. On the other hand, you can book project-related consulting in terms of AURIX itself, functional safety and security. And on the other hand, we are design house. We do the SafeTpack integration in your application as a full service. Maybe you need a customized SafeTpack. We do hard and software development in the context of AURIX and functional safety. And last but not least, we do embedded testing and verification. Let's summarize up. Main advantages of the SafeTpack. It's developed according to ISO 26262-2080. It's similar to the AURIX TC2X SafetyLib. Easy handling, no changeover. It's modular, you pay only what you use. It comes with a demo application. All the configuration tools are included. It can be used either without or without Autosar. It's 100% compatible with the Infineon MCAL. It includes the electrolysis tool to configure the SafeTpack. It provides all the drivers for a watchdog for the Infineon TLF 35584 and A5 and the internal safety watchdog. And SafeTpack saves your time, your money, and your nerves.
Hello, everybody, and welcome to the AURIX Knowledge Lab. My topic for the day is the Advantage ECU. That's more on automotive cybersecurity. Functional safety is the title, but it's going more on an introduction to see how best one can combine the functional safety requirements together with cybersecurity requirements as well, and to find a way to harmonize these two together. So firstly, a bit of introduction towards Escrypt. So Escrypt is one of the leading providers for embedded security. We have a wide portfolio of our products, from design security services to our products, for example, Cyber HSM, which is one of the core focus of today's product presentation, and security services as well. And this encompasses also consulting as well as backend services for the automotive domain, but also for other domain applications. So firstly, what we see that within the cybersecurity domain, there are a lot of challenges, especially in the automotive industry. So what are some of them? You see there are a lot of new regulations which are coming out, new EE architectures. The supply chain is extremely complex and with a lot of parties involved. The complexity is very high. And of course, first and most importantly, there is an impact, direct impact on safety. And how exactly do we go about this? So we see that now the industry is oriented towards a functional safety-based development approach, and security is also a component. But for example, with the new regulations, for example, let's say for ISO 26262, it specifies the functional safety requirements, but many people assume that security is also directly included. It is not. So security and safety are like complementary operations. So you need both to work together and harmonize together to ensure that the overall system is safe and secure here with respect to a vehicle. And so it's also very important to understand that just going towards in a safety-based approach is not enough, and it needs to be orthogonal with respect to security, and that needs to have its own focus. So firstly and foremostly, it's important to define safety and security goals as a core input, and you derive correspondingly your functional safety and your security requirements. So usually within the safety area, there are some methods to usually derive these requirements, for example, using an FTA or an FMEA. And within the security area, you have some methods also to detect and identify some threats or vulnerabilities within your system. For example, using your TARA, your threat assessment and remediation analysis, or deriving a risk-based assessment model as per the NIST publication 830, or a security vulnerability analysis. Or for example, this one more subsection is maybe subject your system under test through penetration testing and a whole bunch of other testing. So to find potential holes or potential attack points and to further safeguard your system. So always a thorough security analysis is required to identify these threats and vulnerabilities. And it's very, very important to understand that you always need to have a system point of view. So for example, safety and security, while of course can be designed for one system, for one small subsystem, it needs to be noted that this system is part of a bigger system in place. So it's always important to know what type of system you're integrating and what sort of requirements are needed to be satisfied, or if the performance figures and the response times accordingly. So a requirement for safety function is determined taking into account some results of hazard identification. So usually your automotive safety integrity requirements, so usually are based on the ASILs. They are directly resulting from analysis of these potential hazardous events. So this is the first introduction, but maybe we just go into a little bit more to see how we could maybe harmonize these two requirements. So there's a lot of research going on within this field, and some researchers from Poland they analyzed these functional safety integration together with cybersecurity, and this is one possible method. Of course, you have different methods. This is more like a more general overview. So firstly, you carry out an intensive security analysis where you identify the threats and the vulnerabilities within your security assets under test. And from these threats and vulnerabilities, you identify the security risks. And for also it doesn't just stop with identifying the risks, you need to also do something about them. So you design your countermeasures and provide both of them as an input towards carrying out a functional safety risk assessment, and the output of that is going to determine your safety integrity level. So if it's going to be from ASIL A to ASIL D. So this is one potential method. Of course, you also have more detailed analysis, for example, carrying out separate functional safety steps for hazard assessment and carrying out separate security-based assessment to find out threats and vulnerabilities, and combining the output of those two activities together into a harmonized risk assessment, which then generates some sort of safety integrity level. So as we see that within the general vehicle, it is exposed and has a lot of external interfaces, and so every device which has some sort of external interface has a potential to be attacked. But it's not just this; it's also the devices within a vehicle itself. It is now the systems are developing into a more smarter infrastructure and integrating into new technologies. So security is of paramount importance. So we highly should not disregard such a critical based approach, because as we know that it can lead to a loss of reputation and, more importantly, a potential loss of life. So the systems for which development has been made within the ECUs or the overall EE architecture, this needs to be secured. So for example, your ECUs can be considered the heart of the automotive network. It's one of the smallest system levels, and it needs to be ensured that it is secure access, it can be securely updated, produced, it has a secure startup, and it has a secure and safe operation. And of course, that you do not need unauthorized people entering into the system or to read this information. And of course, you want the information transmitted between the ECUs to also be valid and confidential. So this comes to the topic of the hardware security module. So the hardware security module is a dedicated hardware component. Here I'm going to be talking about the Evita full HSM. So it's based on the standard of the Evita, which was proposed by the European Union and as European Union study and project. And its sole purpose is the purpose of embedded security on targets which may be a microcontroller or a system on chip. And this HSM is isolated from the host, and it has its own processor as well as hardware cryptographic functions and dedicated memory for the firmware as well as for storing secure keys. So it ensures the confidentiality, integrity, and authenticity of your vehicle software and the data. As a further level of abstraction and optimizing the performance of the hardware security module, you have your firmware, which builds in additional security functions, which may be OEM specific. And it also has its own real-time operating system, which ensures an optimized priority-driven resource utilization and to separate the jobs coming into the HSM. So the HSM functions are usually made available to the host application via a bridge. So it's a API interface, and it serves as the trust anchor for a vehicle systems. So for example, at Escrypt, we have the Cyber HSM, which is the solution provided to secure vehicle communication, within the ECU, and it also offers the solutions for secure booting as well as OEM specific use cases here. So let's go into a bit more detail, but first maybe we need to probably talk about the functional safety of the hardware security module in itself. So hardware design is for the most part done on the basis of some sort of a quality management process. For example, let's say ISO 26262, but sometimes it can be that there is no safety protection or a safety system in play, or safety goal in place directly for the HSM. So this can be pretty unusual, but it makes sense because the HSM in itself does not have a safety goal assigned to it. So it means that the hardware, the HSM, does not have a generic functional safety approach, and it's more, what is more required is a more case-by-case analysis of a functional safety use cases. So one use case here is the HSM is used within the integrated vehicle ECU environment. So the HSM must coexist harmoniously and effectively with a software solution which is providing some sort of safety relevant functions and with safety goals up to ASIL D. And of course, here we take the assumption of it's working within a battery management system. And of course, the safety goal is we want the freedom from interference. That means that this, the system must not interfere with some sort of safety relevant activities, but must continue to provide the performance and provide the security functionalities which are required to ensure message authentication or confidentiality or validation. So what are some of these approaches? So first one, we have approach number one. We do this using domain separation, using hardware functions on the chip. So for ring fencing functionalities, for example, using dedication protection mechanisms or memory protection units. But why is such an approach ineffective? So firstly, you have two separate domains, and it requires to always context switch between one domain to the other, which is very, very bad for performance and leads to an extreme degradation in the performance capabilities. It can lead to an interference with other runtime requirements on the devices. And of course, these hardware options are usually not ideal for low-cost devices, which have a which require high performance but also at a lower cost. So how can we optimize such a use case? So one solution is to have a qualified HSM firmware, which includes some sort of a host driver, which is developed based on the ASIL requirements. So this host driver can be easily integrated inside the host, and it prevents the interference between the HSM and the host core, because it is also developed with the quality management of an ASIL D compliant process. And of course, you do not require any separate partitioning or memory protection. So the HSM in itself is designed as a safety element out of context per the ISO 26262. So in the next use case, we come across a SafeTpack, but maybe I first go through as to say why such a use case may be in the first place required. So we've just seen previously the freedom of interference use case. However, for certain faults within the messaging network of an automotive system, it can have a safety critical impact. So if a message, for instance, is corrupted and the corrupted message is nevertheless forwarded, it can have disastrous consequences. For example, you might receive a false braking signal or some sort of false steering angle or some false parameter from your battery management system, which could be potentially dangerous. So one approach is through the standards itself. So AUTO specifies an end-to-end protection for exchanging the safety relevant data, and the concept detects and handles faults on both the hardware and the software side during runtime communication. And this standard definition is compliant up to ASIL-D. However, there is a huge overhead generated if you have such a system. So you need some sort of a smarter and more intelligent system to provide the sort of service which ensures that no wrong CMAC service or no wrong message shall be validated. So you have some sort of alternative, which is a safe CMAC, which secures safety critical messages using a cipher-based message authentication code. So the CMAC in itself, every message in the vehicle network usually includes this, and it's routed to the hardware security module to validate the authenticity of a message. However, this MAC authentication can also be used as a functional safety measure to detect these corrupted messages. So what is the challenge? Customers require an ASIL-D qualified CMAC verification, which, while avoiding the overhead cost of the overhead cost by the end-to-end protection. So you have a requirement, which is to avoid forwarding the non-authentic messages, and your HSM is usually device as a QM element and with the host as ASIL-D, and you need to have a trustworthy security and safety factors. And of course, it doesn't stop the safety goal from the freedom from interference, and no false MAC shall be verified valid. So what is one solution? So every message within the vehicle network is routed to the HSM. The HSM itself does not is not aware of the CMAC of the message, so it does not store any information with regards to that. So it generates the CMAC separately and for verifying the purpose, and checks if the validity is true or not. And this is done for a bulk series of messages. So you also have the device interface is not overloaded, and it's used only one time to transmit a series of bulk messages. So you improve your performance at the same time, and the safety extension is directly compatible and directly included within the host system. So you directly have some sort of advantage, and this is a very novel system which is developed accordingly. So in the end, what I can maybe end with is to say that the system must always be considered as a separate entity, and the integration must be obviously very carefully taken care of. And the use cases for security with functional safety is an approach which is required, for which analysis needs to be done, and accordingly per individual use cases you need to establish a suitable approach for your particular customer. And yes, that is my presentation.